Hi guys, welcome to this lesson. So in this lesson, we want to look at the ratios of angles between a 0 degree and 360 degree. Ratios of angles between a 0 degree and 360 degree. So we've looked at special angles, which are acute angles, and the special ones are 30 degree, 45 degree, 60 degree. We've also looked at how to define the six trigonometric functions from triangle and circle. So let's look at how we can apply this definition to determine the sign of these functions in the respective quadrant of a circle. So basically, let's define what is known as reference angle. Okay, so reference angle. So if we have the respective angle in the quadrant to be defined as this quadrant. First quadrant, their acute angle. Second quadrant, their obtuse angle between 90 and 180. Third quadrant, the angles there are between 180 and 270. And in the fourth quadrant, the angle there are between 270 and 360. So to define the reference angle, let's say theta prime in the following. So theta prime for first quadrant, okay. So for first quadrant, the acute angle there is equal to the same theta, okay. And then for the second quadrant, the acute angle there for calculation is given to be 180 minus theta, okay. And then for the third quadrant, the acute angle for calculating theta there is given to be theta minus 180, because the angle in the third quadrant are actually greater than 180. So you subtract 180 from theta to get the acute angle. And then for fourth quadrant, the acute angle there are 360 degree minus theta. Okay, so this is how to find this angle. And what is this actual reference angle that we are talking about? Reference angle is the angle that the terminal of the angle make with the x-axis. So in short, what does this definition mean? It means that if you have your circle and then you have the circle divided into the quadrant that we have. So if you have a terminal, a radius forming right angle triangle with a distance here, and then you have theta here, which is this direction r, this is y, and this is x. So this theta, this is x-axis, right? This is y-axis. So this theta, the angle between the terminal, this line is known as the terminal line. Okay, this is the terminal line. The radius is terminal line. So the angle between the radius and the x-axis is what is known as the reference angle. Okay, reference angle. So let's denote it as theta prime so that we will not be confusing it with our angle. So reference angle, which is always an acute angle, is very important when you are calculating angles between a 0 degree and 360 degree. That is the first thing you should find when you are given the angle. So now let's determine, using the reference angle, let's determine the sign of the trigonometric functions in the quadrant, and then we'll be starting with the first quadrant. So the first quadrant in the circle, the reference the terminal line, which is the green line, will be in the first quadrant. Okay, so this is first quadrant, and then the theta there, of course, that the reference angle equals to theta, and it is acute, right? So that is what we have. So if we bring out this triangle and then we draw it out very well, so you will see that this is the positive side of x and this is the positive side of y, and then both x and y, we have plus x plus y, and this is our angle theta, and this is r. So sine theta is positive. It's going to be equal to opposite of hypotenuse y over r, cos theta, which is positive as well, x over r, and tan theta, which is also positive, will be equal to what? Y over x. So in the first quadrant, all ratios are what? All ratios are positive. Okay, so all ratios are positive. So this is what we want to derive, and then the reference angle there is theta, okay, which is acute. Second quadrant. Second quadrant, the line of the angle will move to the second quadrant, which is the second division here. And then here, this is positive y-axis and this is negative x-axis, right? Negative x-axis. So the x value here is going to be negative. So if we draw out this triangle for analysis, what we are going to have is this. So let me extend this line and join it together. So what we are basically going to have is this place. So our theta prime will be here. So we have theta prime here, okay, and you know that the acute angle, which is the reference angle, okay, acute angle theta prime equals to 180 minus theta, okay, because this see where the rotation follows and end here. So this one will be 180 minus theta, and then x is negative, y is positive, r is positive, and then we can take the definitions. So sine theta equals to opposite over hypotenuse, y over r, positive, cos theta equals to adjacent over hypotenuse minus x over r, which is negative, and tan theta equals to y over minus x, which is minus y over x, which is negative. So what can you notice here? So in the second quadrant, okay, only sine is positive. Only sine is positive, okay? Cosine and tangent are negative, and the definition for the angle there is given as what? Theta prime equals to 180 minus theta. Right, for the third quadrant, look at where the terminal line is and the reference angle, which is the angle formed with the x-axis, will be below the terminal line. So look at the line here. So if we bring out this triangle, we basically have it in this form, and then join it together. This is what we have. So this is right angle. So look at where the reference angle will be here, and then this is radius. So this is still negative x-axis, okay, and that is also negative y-axis. So negative x-axis, negative y-axis. So you can see how the sine is rotating, it's changing with respect to the rotation. So the acute angle here, the acute angle theta prime is equals to theta minus 180, okay, theta minus 180 degree, because the angle in the third quadrant is between 180 and 270, so we have to subtract 180 from the given angle to get the reference acute angle. So therefore sine theta will be equal to opposite minus y over r. Sine is negative, sine theta prime cos theta prime equals to minus x over r, which is negative, and tan theta prime equals to what? Minus y over minus x, which is y over x, okay, which is positive. So you can see that in this third quadrant, which one is positive among the ratios? Tangent. So tangent is positive in the third quadrant, okay, in the third quadrant. So that is what we have, and the acute angle definition there is given as this definition, okay. So let's put prime here to avoid confusion, So and lastly we have the fourth quadrant. So the fourth quadrant, the rotation has moved to the fourth quadrant, and look at our reference angle. Remember, the reference angle is always taken with respect to the x-axis, okay. So the angle the terminal make with the x-axis. So bringing out this triangle, what we simply have is this, and then this is positive x-axis now, because this is positive x-axis and this is negative y-axis, so we have negative y. and this is where the reference angle is now, theta prime, and this is r. So the reference angle theta prime here will be equals to 360 minus theta. Okay, and therefore sine theta prime equals to opposite over hypotenuse negative cos theta prime equals to adjacent over hypotenuse, which is positive, and tan theta prime, okay, equals to what? Tan theta prime equals to opposite over adjacent, which is negative. So what did you notice here in the fourth quadrant? So this is the acute angle definition in the fourth quadrant, and then we notice that cosine is positive. Okay, so it means that cosine is positive. So these are the signs of the respective. So